Hi, and welcome back to the great MGB rebuild, part 13. So as you would have seen in previous videos, we're not reluctant to make changes to our car. So looking at the rear suspension, we've decided to make a few changes. We've put in an elliptical spring, which gives a better ride for a road car. It's quite subtle at the beginning, doesn't have the stiffness of a 5-leaf spring. Coupled with that, some 1-inch lowering blocks just to drop it a little tiny bit. And one of the things with elliptical springs is because they've got less leaves in them, they tend to have more lateral side-to-side movement. So fitting a panhard rod's usually a good idea. So here's some details about how I went about making that. So a panhard rod needs to attach to both the rear differential and the body of the car. And the rod goes between the two so that it's braced against the body and stops the diff moving from left to right. So you need 2 points of attachment. You need one attachment onto the axle itself in some manner, and another end onto the body, a strong part of the body in some other manner. A common way to mount the rod onto the axle is to weld a tab onto the axle of the differential, and I didn't really want to do that, so I've designed a bracket that bolts onto the 4 large bolts that hold the bearing retainer flange. So the bracket curves around the differential and bolts onto 3 of those bolts, and you can see that in this picture here, where the curve of the bracket will fit around the diff, bolts on with 3 of these big bolts, as it's not going to come off, and then the bracket on the end which holds the bush for the rod. The other end of the rod needs to go on the body, so you need to find a suitably strong point of the body on which to attach it. It's a bit of a problem on the MG, so there isn't a chassis rail or anything there to bolt it to. So the way I'm going to do that is to build a bracket that sits around the corner of parts of the body, which is actually where the boot depression is. And to give it maximum strength, I'm bolting it to 3 different faces of that corner, and then it'll be supported inside the boot by a bracket where the bolts come straight through the outer bracket, through the boot, and into the inner bracket. You can see that here. So having welded them all up, it's off to the powder coater for them to be painted. And here you can see they've just come back, and you see here the panhard rod itself with the 2 rubber bushes on either end and an adjusting bolt in the middle, so you can extend its length or contract its length and get your differential in the right place. So then it's time to mount them all in place. In this photo you can see the differential attachment. You can see it sort of curving around over the top there. That holds the bush and bracket that takes the differential end of the rod. Here's another angle where you can just see the rod coming in on the top and going across to the pivot point on the axle. On the other end of the rod, you can see the rod coming across here, and then it goes up and onto the bracket that bolts to the body. You can see how it encompasses the corner of the chassis for maximum strength. And then on the other side, on the inside of the boot, we've got its matching bracket. So I'm pretty pleased with how this turns out. Here you can get a bit of a view of the rod as it goes along. When the car's down on its weight, the rod sits almost through the middle of the differential line and sits exactly horizontal to the ground with its normal loaded weight. In that manner, it should swing up and down around the centre line. So while we're on suspension changes, we're making a few changes to the front end as well. Included in that is new springs, which are a different material than is normally on the old ones, a little bit more resilience. These are also 1 inch lower, so we have a nicely balanced front to rear. And the next thing we're going to do is actually upgrade the front sway bar up to a 3/4 inch bar. With the MG, you don't appear to need a rear sway bar as much. It's more important that the front one be upgraded a bit, and they work quite nicely then. One of the problems you seem to have with front sway bar, particularly when you upgrade it and it's thicker, the radius corners when they bend it is obviously a bit different to the standard bar. And what happens is the vertical riser you can see in this picture, that's the rod that comes up, that's on the right hand side, because the sway bar is longer, it tends to push that rod towards the rear of the car backwards. And you can see the top eye of the bolt there. It actually strikes, or just about strikes, that bolt that's retaining the rubber stoppers on. You can see in this picture there is a small gap, but once you put the sway bar in, it pushes it back even more. So it's necessary to try and offset that, pull it back into line, so have that rod vertical if you can. So the way I'm getting around this is I'm building an offset plate. So where the sway bar bolts onto the chassis, I've built a plate that I can bolt onto the chassis, and then that spaces the holes for the sway bar mount further away or towards the front of the car, effectively pulling the whole bar forward. That gets my attachment rods away from those stopper bolts and makes them nice and vertical. So I mentioned in one of the previous videos that we're using a digital gauge, and that gauge relies on a pickup that you put on the tail shaft to actually sense the rotation speed and hence the speed of the car. So that pickup needs to be mounted firmly to the gearbox so that it doesn't move in relation to the tail shaft. And then there's a little flange you put on the tail shaft itself that goes past the face of this pickup. So I originally made this bracket, which bolts onto an existing hole in the gearbox, but it's too big. When I went to fit the gearbox into the tunnel, it's a very tight fit where the gearbox goes through the chassis, and it just doesn't work. So I had to modify that, so that actually took quite an effort. Put the gearbox in, pull the gearbox out, put it in, pull it out, put it in, pull it out, and eventually I came up with this design, which is obviously much more compact and fits up in the tunnel quite neatly. So since I'm still waiting on the engine, I decided to fit the gearbox into the car, and we'll put the engine onto the gearbox later while it's in situ. Bit unusual, perhaps. I know some people have do it that way, and some people pull the whole engine and gearbox out in one assembly, which is what I've done previously. But since I haven't got an engine, I thought I'd give myself something to do by fitting the gearbox now. So that's all in place. So, of course, having now put that in place, you then turn around and you realise that you haven't actually put the wiring loom on that goes to the reversing switch and the overdrive switch. And that wiring loom, of course, goes on to P-clamps, that goes on to nuts on the gearbox, which are all on the top of the gearbox you can't get to with the gearbox in. So you pull the gearbox out again, drop it down on the ground, put the loom on, put all the clamps on that you can't get to later, and put it back in again. That's about the sixth time now. So with the gearbox physically in place, the last thing you do pretty much is to put the gear stick in. And the gear stick has this little nylon bush on the bottom where it goes into the shift mechanism. I don't know who designed that, but it's crap. You can't get to it. You butcher them trying to put them in. They're really, really hard if it's a new nylon bush. I ended up making my own out of a different material, Delrin, I think it is. So I turned it up and made a better one that actually fits into the thing properly, and you can actually get it in place. I must have struggled with that for a day in order to get that bush in without damaging it, and end up with a change mechanism that had no slot in it. Yeah, beautiful piece of English engineering. One last little thing that I've done that I guess I didn't have to do, but I did, is I filled in these two vents on the front valence. I don't think the 1970 should actually have those holes in there. Anyway, I put a stainless steel mesh in them just to cover them up a little bit, make it look a bit different. So that's done, and now, as I said previously, I think it is done with the exception of the engine. So I think I'll wrap this episode up, and when the engine comes in, we'll generate the next episode. Thanks for watching.